Therefore, we have the first three trigonometric ratios which are found for tan A equal to 3 by 4 as sine A, cos A, and tan A, which I have obtained as each of them being this. Now, once I got the three trigonometric ratios, sine, cos, and tan with their respective values, then I use the formula for cosecant, secant, and cot with 1 by sine A, and secant is 1 by cos A, and cot is 1 by tan A. Therefore, my cosecant A will be 1 by sine A, so 1 by 3 over 5. So reversing the digits, I get, reversing the numerators and denominator, I get cosecant A is 5 by 3, secant A is 5 by 4, and tan A is 4 by 3, is how I obtain the 6 trigonometric ratios, sine, cos, tan, cosecant, secant, cot with their values. Now let's see how we can find the trigonometric ratios of some specific angles. Because trigonometric ratio is identified with each of the ratio connected to the opposite side, adjacent side, and hypotenuse of a right angled triangle, there are some specific angles for which we will try to find the trigonometric ratios. The specific angles here considered as 30, 45, and 60. So let's see how we can connect the trigonometric ratios for these three specific angles. Initially, to start with 45. So let me take first as theta equals 45 degrees. And let's see how the trigonometric ratios can be found for finding sine 45 degrees, cos 45 degrees, and tan 45 degrees, and the respective cosecant, secant, and cot using the triangle properties. To start with this, if suppose the angle theta is 45 is taken for a right angle triangle where this is 45. So if one of the angle is 45, then immediately this being 90, 180 minus 90 plus 45 will also make this as 45. Therefore, this angle also will be 45. This makes us understand that this triangle is an isosceles triangle with this equal to this. Therefore, when I take the triangle ABC, AB is equal to AC because this is an isosceles right angle triangle. Angle B equal to angle C. So AB equal to AC. So using this property, let's see what we will get for the value of sine 45. To start with, I have, let me just take each of the sides as A and A because they are equal. I take this measurement as A, so this will also be A. So let me see how I can find BC initially, because to find sine 45, which is opposite by hypotenuse, I need the hypotenuse first. So by using the Pythagoras theorem for the triangle, I have BC squared equals AB squared plus AC squared. This is by the Pythagoras theorem. That implies my BC squared, which is hypotenuse squared, can be found using the right hand side of the Pythagoras theorem, where AB is already known to be A squared plus AC, which is equally same for this isosceles right angle triangle, is again substituted for A squared. That implies my BC is root of A squared plus A squared, which is twice A squared. So this comes out to be A root 2. Therefore, my measurement BC is A root 2 out here. AB is A, AC is A, BC is A root 2 units. And using these three dimensions, it is very easy that I can find sine 45, which is sine theta, is opposite by adjacent, opposite by hypotenuse. Therefore, here the opposite side is A because I consider this angle 45. Then opposite to 45 is opposite side, which is A, and hypotenuse is obviously a root 2 is what I get. So cancelling a, which is non-zero because this is the length of the side, I get this to be 1 over root 2. Therefore, sine 45 degrees is 1 over root 2 is how we derive for sine. Now let's see how we can derive for cos. Cos 45, I get this as adjacent by hypotenuse with the formula as we have. Adjacent side, which is AB, that is A. This is the adjacent side, this is the opposite, and this is the hypotenuse. And hypotenuse is A root 2. Again, I cancel, I get 1 over root 2. Therefore, my cos 45 is 1 over root 2, which I get. That means sine 45 degrees is 1 over root 2 and cos 45 degrees is also 1 over root 2. The special angle 45 degrees taken out here gives this. Finally, we'll try to find tan 45 and see how we get the value. Let's see for tan. Now, as I see here, my tan 45 degrees for the triangle ABC is opposite side by adjacent. As we have the formula O by A, I can substitute to get opposite side, which is A, and adjacent side, which is also A, so that on cancellation it gives 1. Therefore, tan 45 degrees is said to be equal to 1, is how we understand tan 45. So now that we have obtained sine, cos and tan, we just try to understand that there is a relation between sine and cos. Let's see how the relation comes here. Clearly, if I consider sine 45 over cos 45, let's see what I would get. If I divide the ratio sine with cos, I get 1 over root 2 is sine 45 and cos 45 also is 1 over root 2, whereas this gets cancelled to give 1, which is equal to this. Therefore, this makes us understand that, therefore, tan 45 is said to be equal to sine 45 by cos 45 is what we get, in this case being equal to 1. So we got three trigonometric ratios, sine, cos and tan. Equally, we will try to find cosecant, secant and cot in the similar manner as we have done for sine, cos and tan. And sine, cos, tan connected as tan equals sine by cos. Now let's take the three trigonometric ratios which I have found, that is sine 45, which is 1 over root 2, cos 45, which is also 1 over root 2, and tan 45, which is 1. This leads each of them to find cosecant 45, which is reverse of 1 over root 2, that is root 2, and secant 45, which is reverse of 1 over root 2, that is root 2, and cot 45, which is reverse of 1, which is 1, is how we understand the reciprocal or the reverse trigonometric ratios and the three trigonometric ratios for the special angle theta equals 45 degrees. Secondly, we will try to see what exactly is sine 30 or cos 30 or tan 30, and then we find for special angle 60 degrees. Now the turn comes on identifying for 30 and 60 degrees. So now that we have found for the special angle 45 degrees each of sine, cos, tan and cosecant, secant, cot for the angle 45 degrees, switching on to the special angles 30 and 60, let's consider, before starting with the special angle, we consider with the previous case that tan 45 was sine 45 by cos 45, and in any case, if we take tan theta is opposite by adjacent, then this can be divided with hypotenuse on both sides. Therefore, O by h is sine theta and A by h is cos theta. Therefore, tan theta is defined as sine theta by cos theta. That implies if I find the sine and cos trigonometric ratios, I need not find tan, because tan is simply the ratio of sine and cos. Therefore, it is very important that we find sine and cos, and then indirectly the division of that gives me tan. So let's see how we can find sine 30 and cos 30 and sine 60 and cos 60, which gives us the rest of the trigonometric ratios based on sine and cos. So let's consider an equilateral triangle for which we are going to derive for 60 and 30. So when I consider an equilateral triangle, I assume that an equilateral triangle has all sides equal. We know that as a property. Now, since all sides are equal in an equilateral triangle ABC, I simply see that for equilateral triangle, each of the angle is equal, which is 60, because 60 plus 60 plus 60 is 180. Therefore, each of the angle will be 60. This will also be 60. Now, the other important property is that if I drop a perpendicular from A onto BC onto the D, then this is exactly equal to this, or D bisects BC, and AD is the angular bisector of BAC. Now, since AD is the angular bisector, each of this must be equal. That is, this whole thing being 60 divides equally into 30 and 30 degrees, where 30 plus 30 is 60, 60 and 60 for an equilateral triangle. Now, using the property that D is the midpoint, this is the angular bisector, and getting the angle as 30, I split this separately into two right angle triangles through which I am going to find each of the special angles 30 and 60 for their trigonometric ratios. Now, before we do, let each side equal 2a units. That is, I take each side of the equilateral triangle to be 2a, and this is 2a, and this is 2a, is what we get. So that this gives a, and this is a, because D is the midpoint of BC. D exactly divides BC in the half. 2a implies each of them would be a. Now, with this picture of the triangles, let's consider right angle triangle ABD. Consider triangle ABD and see what exactly happens in ABD. Now, in triangle ABD, if I wanted to find sine 60, then that is opposite by hypotenuse. And let's see what exactly is the opposite side and the hypotenuse. So in triangle ABD, I clearly see that angle D is 90. Therefore, ABD is a right angle triangle where I can use Pythagoras Theorem, which says that AB square equals BD square plus AD square, or AD square plus BD square. So using the Pythagoras Theorem, I get this, where if I substitute for AB as 2a, because my distance AB is 2a, I can further simplify this to be 2a whole square equals AD square plus BD square. But what is BD? We have already identified BD to be a, which can be simplified to get AD as BD as a, so a square. So let's take all a terms to the right and AD square to the left. That implies I get AD square equals 2a whole square, which is 4a square, and a square, when I bring it to the other side, becomes negative a square, which on further simplification gives me AD square equals 4a square minus a square is strictly 3 times of a square. Therefore, I get AD square equals 3 times of a square, where square brought to the right gives me the root. That implies AD equals root of 3a square. I don't take the negative because lengths or the line segments cannot be negative. Therefore, plus root of 3a square is a root 3 units. I get AD as a root 3 units. is what I get here. So here, this is A times root 3 for the distance AB. Now using this, let's find sine, cos and tan for 60. 30, let's take for 30 degrees. So for the special angle theta equal to 30 degrees, I see that in triangle ABD, my sine 30, if I observe here, is nothing but sine 30 is opposite by hypotenuse. But what is the opposite side here? My opposite side of 30 in this triangle is A, and my hypotenuse in this triangle is 2A, so that I get the answer. Therefore, my sine 30, which is opposite by hypotenuse, is A by 2A, because opposite to 30 degrees is this side and opposite to 90 degrees is this hypotenuse. Therefore, opposite by hypotenuse implies A by 2A, which in turn on cancellation gives 1 over 2. Therefore, my sine 30 is 1 over 2 is what I get for sine 30. 1 over 2 is the answer for sine 30. Similarly, let's find cos 30. So in triangle, I reconsider the triangle ABD, the same triangle ABD. If theta is 30 degrees assumed here, then for this theta, my cos 30 is clearly adjacent by hypotenuse, but adjacent to 30 degrees is this side which is adjacent to that is A root 3, and my hypotenuse here is opposite to 90, which is 2A. Cancelling this, I get root 3 over 2 as cos 30. Therefore, cos 30 degrees is root 3 over 2 is how we get cos 30 connected with the trigonometric table to the trigonometric triangle. Now there are two ways of finding tan 30. One is by using the formula opposite by adjacent in the same triangle, or by using the formula tan theta equals sine theta over cos theta. So let's see with the formula connected with sine, cos and tan. So for triangle, for theta being 30 degrees, clearly we know that tan theta is sine theta by cos theta as derived in the previous session. We get tan theta equals sine theta by cos theta with theta equal to 30 degrees implies tan 30 is sine 30 by cos 30 because theta is 30 degrees. So to find tan 30, we have already found sine 30, which was 1 over 2, and we have found cos 30, which was root 3 over 2. Therefore, on simplification, I get this to be 1 over root 3 is tan 30, which is obtained as the answer. So this is one of the methods of obtaining the tan value from sine and cos values. If the sine and cos values are already known, I need not use the triangle and its trigonometric ratio opposite by adjacent. That is one way of doing, and the alternative method, if I know the sine and cos, is by just connecting tan with sine and cos, is how we get tan 30 equals 1 over root 3. So now that we have found sine, cos and tan for theta equal to 30 degrees, let's see what will be the respective cosecant, secant and cot, as we have already derived the formulae for the reverse trigonometric ratios. So my sine 30, cos 30, tan 30, which are obtained individually as 1 over 2, root 3 over 2 and 1 over root 3, clearly implies that my cosecant 30 is 2, secant 30 is 2 over root 3, and my cot 30 is root 3, is how I understand the 6 trigonometric ratios in their own respective manner. Same way, I have to find the trigonometric ratios connected with 60, then I take this angle and I use opposite by adjacent, opposite by hypotenuse for the triangle, so that by using triangle ABD, if I want to find sine 60, then I get this sine 60 as opposite by hypotenuse which is opposite by hypotenuse, is a root 3 by 2a, which is root 3 over 2. And my cos 60 can also be obtained by taking adjacent by hypotenuse, which is a by 2a, which is 1 over 2, is what I get when I divide. Next, I take tan 60, which is sine over cos, then I get root 3 over 2 by 1 over 2, which I get as root 3. This is how I get the three trigonometric ratios for theta equal to 60 from the same triangle and by the same procedure. Once I got this, then immediately my cosecant, secant and cot would be 2 over root 3, and secant 60, which is reverse of cos, would be 2 by 1, which is 2, and my cot 60, which is reverse of tan, is 1 over root 3, is how I obtain the 6 trigonometric ratios for theta equal to 30 degrees and theta equal to 60 degrees. And finally, the three special angles 30, 45 and 60 have their own trigonometric ratios with their own values.